Okay, what we're going to look at in this video is the type of log equation where you have logs on both sides of the equal sign. Okay, in order to solve an equation like this, what we're going to need to do is use some log properties to condense the two logs on the left hand side, and then ultimately we will drop out the logs towards the end. So first thing we need to make sure here is that they are all log base 5. Okay, which they are. So now I'm going to use log properties here to condense these two logs on the left hand side. So the important idea here is when you add logs, you multiply their arguments. So I'm going to have to multiply the 6 to the x minus 3. So on the left hand side, what I'm going to get is I'm going to get log base 5, and then I'm going to multiply 6 with x minus 3, so I'm going to get 6x minus 18 here. Again, being careful to distribute this 6 into both the x and to the negative 3. And then on the right hand side, I'm going to take this coefficient of 2, and the property says that we can take coefficients and we can write them up here as exponents. So this is going to turn into log base 5 of 6 squared. Okay. Now the reason I'm doing this is because if you notice on both sides now I have log base 5 here of this 6x minus 18, and then we have log base 5 of 6 squared. Okay, so since you have the log base 5 on both sides of the equation, we can drop out the log. So what I'm going to have left is just 6x minus 18 equals 6 squared. Which, if I continue to solve this for x, I'm going to get 6x minus 18 equals 36. Add 18 to both sides. So 6x equals 54. Therefore x is going to equal 9. Okay, so this should be our final answer for x. And you can check this by substituting x back into the original problem. So if you check log base 5 of 9 minus 3 plus log base 5 of 6, this is the same as 2 log base 5 of 6. And this is pretty quick to check because right here you have log base 5 of 6 plus another log base 5 of 6. So 2 log base 5s of 6 is going to equal out here, so I know this is actually the correct answer. Okay, let's give you one sample problem to try. So let's go solve log base 3 of x plus 5 plus log base 3 of x equals log base 3 of 6. Okay, so let me give you some time to try this on your own, and then we'll go over this. And if you need more time, just pause the video. Okay, so hopefully you found some success with this problem, and you should notice, again, every term here has log base 3. Okay, so what I'm going to need to do is condense on the left hand side, and then I will drop out logs. So on the left hand side, when we condense these two logs, again, when you're adding here, you multiply the arguments. So I'm going to multiply the x with the x plus 5. So I'm going to get x squared plus 5x. Being careful to distribute the x into the x and the 5. And on the right hand side, we already have log base 3 by itself, so there's no work to do there. So what we're going to get, since we have log base 3 on both sides, we can drop these out. So we're going to get x squared plus 5x equals 6. So here we have a quadratic because we have the x squared term and we have an x term. So I'm going to either solve this by using quadratic formula or factoring. This one is going to factor for us, so I'm going to set it equal to 0. And when we factor this out, we get x times x gives me the x squared, and then I'm going to use a plus 6 and a minus 1. Those will multiply to give me the negative 6. And then if I check, this is 6x in the middle and minus x on the outside, so that's going to give me this middle term here of 5x. So therefore, I could set each of the factors equal to 0. So therefore x equals negative 6. Or if I set this factor equal to 0, I'll get x equals 1. Okay. Now, when you have these log equations, we do want to be careful to check our answers because by log properties we cannot have any negative arguments in here. Okay, so if I check, I'll see here that actually negative 6 is not going to work for us, because if I substitute negative 6 back in, I'm going to get in two different places actually. I'm going to get negative 1 here, so we cannot have that, and we have the negative 6 here. So this is no good. So negative 6 is not going to be one of our answers. If I check when x equals 1, if I substitute this in, this seems to work itself out a little nicer. So all the arguments are positive, and if I continue to check all the way, log 6 plus log base 3 of 1, this equals log base 3 of 6. And this does because when you add, you multiply. So 1 times 6, this is going to be 6. So therefore, final answer is just going to be x equals 1, and not this negative 6. Again, because you cannot have negative arguments, and when you substitute back in, you see over here it does not work.